Hello all and welcome back. So in this video, we are going to find the middle of our linked list, something which we did in the last video, yes, but I'm going to introduce you to a better approach through which you can find it in a quick, won't say it's quick way, like the complexity is same, but overall this method is a lot intuitive and the same will be used a lot in solving some questions when we move forward. Okay, so let's get started. Now to find the middle of a linked list, I will first like you to think of something. Okay, let's say this is a track, everyone. So let's say this is just a racing track. Okay, two players are standing here. First one is on the starting, and let me make another track for the view. And this is the second person. Okay, this person, this person, the yellow one, it runs 2x, or rather twice as fast as orange. Okay, so what I'm saying is this person, okay, let's say if the speed of my orange person is s, he will run at a 2s speed. Okay, now just imagine if they both start to run together and say at a point, at a particular point, when my yellow will reach to the end, where do you think the orange one, the first person, should be? I think it's pretty intuitive. You can just pause the video and think a little on that as well if you want. So just that, let's say someone is there who runs twice as fast as you. You both start to run at the same time. The person completes the race. Let's say this blue line is completing the race. Where will you be? I think that you will exactly be at the half of your track. So let me write this down. When the yellow person completes the race, orange will be at half. Pretty straightforward, intuitive thing. Nothing new I'm introducing. If someone runs faster than you, he will be, when he finish, you will be at half. If someone eat anything twice as fast as you, when he finishes his meal, you would have finished half of your meal, right? So this is actually a two-pointer approach, which I want to explain you to use. Two-pointer approach. So the understanding is same. What we are going to do, let us now use the same concept in linked list, everyone. I hope this intuitive example will help you to remember this. Let's say if I have a linked list, right? What I'm going to do is I will just take two pointers this time. So up till now, we were always taking temp, just a single pointer. I'm going to take a fast and I'm going to take a slow. Again, the same color coding so you can relate. The overall idea is we will move the fast twice while slow moves once. Right? So the idea is the same, everyone. The fast one is going to move two steps every time. Okay. And we have seen that we can use something like this. So this is a perfectly valid thing, right? Head is equals to head next dot next. So we can just club and keep on writing this till we want. Just that no none should be encountered, right? There should be no none which is there. So when we increase our pointers, we should just make sure that none of them is none, right? And ideally, I need to just check the same for fast because my slow will never be none. If we start with a linked list that is having some nodes, fast will become none first, then slow, right? Great. So let us just draw a few iterations so that you can see the same. Let's say this is the first. Now in the second iteration, everyone, slow will be here while fast will be here, right? So I hope you're able to see that fast will be on 3, slow will be on 2. On third, slow will be here while my fast will be here. Now at this particular point, the next of fast is none, right? So the way I will be updating them is going to be something like this. Slow will be equal to slow dot next, and fast will be equals to fast dot next dot next. I have to make sure of two things. First, fast should not be null because I am calling this next on fast, so it should not be null. And through this, you would have understood that we have to just check for fast because slow will never have that issue. Second, fast dot next should also not be null because I'm calling dot next on this fast dot next both, right? So in this condition, I feel the two condition which we talked about, okay, we have actually reached the condition. And if you will see this time, slow at mid, and I can just return the slow pointer, which is going to be my middle. Okay, everyone. I hope this approach is a lot clear. I have drawn the full work around in front of you. We are going to see the same in visualization as well. Don't worry. But let us now try to code this. Okay, great. So let's move forward. Yeah. Def middle of linked list using slow and fast. Okay, a little long name, but should be fine. Head is this. I can just copy this. That should not be a problem. This is going to be still the same. Now what I have to do is slow is equals to head, fast is equals to head. Okay, so I made two things, two variables, slow and fast. Great. So am I getting error here? If okay, so indentation issue. Good. Now I just have to make sure that while my fast is not none and fast dot next is not none. If both these conditions are valid, then let me keep on moving my slow. Slow we have seen is going to move like this. Fast we know it's going to move like this. Now since we have checked for both these conditions, we can always be sure that this will never give me a none that attribute error. Okay, it is also known as null pointer exception in Java and C++, a very common error which we face while programming. So because I have handled this and I'm pretty sure that if I return slow, it will be at the middle. So let me write this down. When fast reaches end, slow will be at middle. Okay, all. So great. Let us just check this code quickly. Cool. Let me clear this and let us run this. See, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 3 is the middle, seems to work. 4 is the middle, seems to work. Right? So yeah, that's a perfectly valid code, everyone. We are able to work out on the same. This is also a question on lead code. So 876 question, pretty easy. I think we should be good to try and work on this now. We are given a head, we are given a self. Okay, so this is a solution. So we have to just use the head, right? Don't worry on anything else. We just have to use the head. And I think rather we should just copy this whole code and it is going to run absolutely well. If we just copy this and paste it here, just let me do the indentation. And I'm pretty sure it is next only. So let us check this as well. Great. So yeah, I hope this is a lot clear to each and every one of you. This is the case. Let us run this once. Okay, it is giving an error. Indented block. My bad. Indentation was not handled. Now let us run this. Aja, in this question as well, everyone, it's the same. So for odd length linked list, this is the middle. For even length linked list, the second one is the middle. Nothing else, right? This is the just all the things. Let me submit it. Able to see this, right? So beating everything should be fine. We are able to submit and all is good. Now let us quickly see the same ones, everyone in this as well. So what we have to do, let me just copy all of them. The functions are already there. So let me copy this and let me remove this middle of list. Okay. So that it doesn't pop up anywhere. Let us for the time being just also not print because that's going to increase lots of steps. I don't want lots of steps, everyone. So again, I will just explain you what exactly is happening here. We have the node, something which we have created and been using since in the linked list. We have the create linked list from a list or some sequence. To better create our linked list, we don't have to give input always. We have the length of a linked list, something which I can actually remove now. We don't need this for this particular code. Then I'm creating my head odd and head even the same way. Then I'm using this middle of linked list using slow and fast, something which I want to showcase you in visualization so that it gets clear properly. Okay. Head odd mid, head even mid. Once I get this, I'm just printing the data. Okay. So I'm pretty sure till now, we are not going any fast. Everything is clear. We are just going slow. Okay. Slow is our main pointer. That is what we will also do. Great. So let's move forward, everyone. Now, if you will see, we just have to run till we are able to create these lists, right? So let us just jump to that point where we know these lists will be created. Something which we have seen already in the last module. Great. So instead of this, yeah, this is the exact step where I have to stop. See everyone. So head odd, this is the odd list. Head even, this is this whole a little big is the whole list. Okay. So yeah, should be fine. Let me try to zoom out a little bit. So hoping that okay, let's keep it zoom in only so that the visibility is not messed up at your end. Now let us try to find the middle of our odd first. Okay, great. So let's see. Head is not none and head dot next is also not none. So let us move forward. Great. I'm getting slow and fast. So slow and fast both are at head. Let's move forward. Now let me just move it here so that I can show you this whole execution. Code we already know, it's an easy code. I want all of you to focus on these two pointers, slow and fast. Okay. Slow moves here because fast was not none and fast dot next was also not none. Let's see how fast is going to move. Fast move to this particular step. So let me just showcase this to you everyone. What exactly happened? Slow was here. Slow was here. It just took a single step. On the other hand, fast was here. It took two steps and it is here. So this is what how we are controlling that fast is twice as speedy as slow. Okay, great. Let us move. Still, we are gonna check is fast none? No. Is fast dot next none? No. Let us move. Slow move here. Let us move the fast as well here. Okay. Now again, this is at the condition. Pay attention. This is the next line to be executed. Here, if we see here, fast is not none. No, fast is not none, but fast dot next is none. This is none, right? So with that understanding, actually, we should return the slow pointer and you can see that it is on the middle, right? Let us move forward and see the overall, this function will now exit head odd mid. See, we are at this particular node, right? Great. So now let us see the visualization for even as well, everyone. Pay attention. So again, the same thing is going to happen. First, the basic condition that is head even, sorry, head none or head dot next none. That is not the case. So slow and fast are going to get created. Okay. Let me help you visualize by this. So let me just keep the next pointer somehow. Oh, great. So yeah, we will just see how the slow and fast are moving. Pay attention, everyone. Okay, it's going to be a little difficult, but let me try that. No worries. See, I will just scroll and show you. So slow is moved one point, whereas fast has moved to this point, right? Great. I will just repeat. I will just show you how it happened. So slow and fast both are at the same point. Okay, slow and fast both are at the same point. What exactly is happening here? We have to move them one by one, right? First, slow is going to move here. Fast is going to move 2 steps. Let us do next. Okay, see, slow moved here. This is slow, and this overall is fast. So this is fast, right? Great. Now let's move it again. Fast is not none. Fast dot next is also not none. Let us move forward. Slow moved here where fast was, and fast is now going to take a jump more. Now this time fast is here. Again, fast is not none. Fast dot next is also not none. So we are going to do one more iteration. So slow is currently here, everyone. Okay, I know it's a little bit messy because of some long linked list, but I hope you're able to see the same and understand it again. I want to really make sure that it sits in your head as a visualization. That is how I like to teach each and every concept so you never make a mistake, right? Now, because this is here and this particular thing is here, we just have to do next, next. And once now my fast, okay. So this time actually what would have happened? Fast was actually here. Fast became, sorry, fast was here. Okay, in the last step. So pay attention here, everyone. This is my fast pointer, right? This is the fast pointer. You can see that it is pointing to this 5 node. When it will jump to fast dot next, this is 6 dot next. It is going to become none. And slow is going to move to this 4 pointer. And this is something which we can see. Fast is none, slow is at the 4 pointer. Now, because we are going to come out of our loop, we can just return this, and head even mid is something which is at 4. Okay. So yeah, but it's, I think it's a little bit, I think it is manageable, not an issue, but always it's good that you take some bigger linked list only, right? Because on smaller one, we will not be able to see the whole movement. So yeah, now we have the head odd middle and head even middle. We can just print the data and we can see the answer. 3 and 4. Makes sense? We have the linked list in front of us. 1, 2, 3, 4, 5. This is the middle. 1, 2, 3, 4, 5, 6. This is the middle. We are saying that we are taking the second middle. Not a problem, right? Great, everyone. So I hope this approach was clear. Now, this fast and slow pointer approach, it is actually used at lots of questions. I'm gonna make sure that I give you those questions along with their solution, very fabulously explained. So please make sure that you see and you think, because this is now one more approach which I have unlocked for you when you try to solve the questions which are of linked list. Okay. Thank you.